Imagine if something we have always considered as waste could actually become a solution to the problem we face every day. Every day, we produce plastic waste that can continue to accumulate and harm the environment. At the same time, we rely heavily on energy-consuming cooling system just to achieve thermal comfort. Through this research, I aim to address both issues to a single innovative approach by re-engineering plastic waste into aerodynamic modules that create passive cooling using the Venturi effect.
Hello, my name is Rania, Artanti, Helga, Putri, and I represent re-engineering plastic waste into an aerodynamic modules using the Venturi effect.
Amid the growing global environmental crisis, plastic waste has become one of the most critical challenges we face nowadays. At the same time, the demand for thermal comfort in buildings, especially in tropical regions, continues to rise, resulting in increased dependence on conventional cooling systems such as air conditioners. The situation highlights two interconnected issues: plastic waste and energy consumption. Therefore, an innovative solution is needed to address both problems. According to a study titled Sistem Ventilasi Alami untuk Kenyamanan Thermal, natural ventilation plays a significant role in improving indoor thermal comfort, particularly in tropical climates, by optimizing airflow and enhancing heat dissipation without relying on mechanical cooling systems.
The study emphasized that airflow is a key factor in achieving thermal comfort, as increased air movement can create a cooling sensation even without a significant decrease in air temperature. Although the temperature reduction achieved by this system is relatively modest, it still contributes to passive cooling. Furthermore, the study suggests that the effectiveness of such systems is highly influenced by the geometry and design of the airflow pathway. Building upon these findings, this research proposed an innovative approach by re-engineering plastic waste into aerodynamic modules that utilize the Venturi effect to enhance passive cooling performance. What makes this research unique is that it doesn't simply reuse plastic bottles as ventilation tools, but redesigns them into aerodynamic nozzle-like structures that are specifically optimized to enhance airflow velocity. Unlike previous approaches such as the echo cooler, this study focuses on controlling the geometry of the structure to maximize the Venturi effect. This means the innovation lies not only in recycled plastic waste, but also in integrating engineering, design, and fluid dynamics principles to improve cooling performance. The Venturi effect is a fluid dynamics principle where airflow passing through a narrow section moves faster and create lower pressure, producing a natural cooling effect without additional energy. This research aimed to engineering plastic waste into aerodynamic modules that optimize the Venturi effect and evaluate their effectiveness in reducing temperature and improving indoor thermal comfort. Used plastic bottles are cleaned, cut, and reshaped into nozzle-like structures to maximize airflow velocity. The modules are installed on a panel simulating wall ventilation, where a fan represents natural wind. Temperature is measured before and after airflow passes through the models, and airflow changes are observed. The experiment is repeated several times to ensure continuous result. The results show that the plastic bottles modules increase airflow velocity and create measurable cooling effect. Compared to conventional ventilation, the optimized aerodynamic design improves airflow performance more effectively. In conclusion, this study proved that plastic waste can be transformed into an innovative passive cooling system that is energy efficient, environmentally friendly and low cost.